All right, my friends, I actually really hope you ran into trouble with this one because it turns out you actually cannot apply the comparison test to a problem like this one. And that is the point of part C. And so let's make sure that you know why. So first of all, what would you compare it to? So I personally would see if I can get rid of that little -5 there. So the sum as n goes from 1 to infinity of 2 over 3 to the n, which if you factor the 2 out, you'd have the sum as n goes from 1 to infinity of 1 over 3 to the n, which, my friends, is a geometric series with a common ratio of 1/3. And so I would say which is a convergent geometric. And then why am I saying that? Because the common ratio is 1/3. It's between -1 and 1, right? Okay, so if I'm comparing it to something that converges, so here's the geometric I'm comparing it to, right? For my logic to make sense, the comparison test, I would need these terms to be below, right? To say if the other one adds up to something finite, this one must as well. And so, but the problem is that you're actually dividing by a smaller number in this one. So you'll get a bigger result. And so we'll say, but, sadly, I don't know how to punctuate that, but sadly, do you encase it, commas? Sadly. Anyway, 2 over 3 to the n minus 5. Unfortunately, that would be higher, or it certainly wouldn't be less. Anyway, isn't that horrible notation? I'll say it is higher. Anyway, and so we'll say sad. So the point is that the comparison test cannot be applied. But hey, stay tuned, because while the comparison test cannot be applied, what's called the limit comparison test, which we'll talk about in part 2, will work like a charm. There we go. So I did want to give this example, though, so you could see that you really do have to check your positioning before you apply that comparison test. And they have ways on the AP exam of checking to see if you know your theory or not. Okay, so the last thing that I would like to do as part of this video is see if we can update your flashcard collection to include the following: the formula for the infinite sum of a geometric series, nth term test for divergence, the integral test, p-series test, comparison test, and then we have the limit comparison test coming in the next set of videos. So that's a little premature there with the limit comparison test, but let's make sure we can update your flashcard with the rest. Okay, so totally up to you if you'd like to pause the video and see how many of them you can get right, or if you just want to go through and write them with me. So the formula for the infinite sum of a geometric series, I've learned that for this to really help you the most with the AP exam, what we need to do is show both sides, the term-by-term expansion side, and then what the answer is, okay? So if you have a first term plus a first term times a common ratio plus a first term times a common ratio squared plus a first term times, oops, let's write this correctly, times a common ratio cubed, etc., forever and ever and ever, it turns out that you could get the answer for all of those terms by taking the first term and dividing by 1 minus the common ratio. But that's only true if your common ratio is between what two numbers? That's right, -1 and 1, not including those numbers, okay? All right, my friends, I hope that makes sense. You do want to know the expanded side and the condensed side. The expanded side is the a plus ar squared plus ar cubed, etc. And then the condensed side is that the sum would equal a over 1 minus r. Okay, the nth term test for divergence says if the limit as n approaches infinity of the way the terms are defined, if they don't equal 0, then what would that mean about the sum of all those terms if you're adding up infinitely many of them? Whoops. It would mean that the sum diverges, okay? Be careful, just because your terms do go to 0 will not mean that your sum converges. So do not read more into that one than there really is. That can be problematic. Okay, let's see. What on earth was the integral test? There were 3 conditions. They were if f of n equals a sub n, where has all positive, it was positive, decreasing. Oh wait, no. If f of n equals a sub n is positive, continuous, and decreasing, then the integral from 1 to infinity of f of x dx and the sum as n goes from 1 to infinity of a sub n either both converge or both diverge. So basically whatever one does, the other one will do as well. Okay. All right, p-series test is actually a special case of the integral test. So let's see, it says the sum as n goes from 1 to infinity of 1 over n to the p when will it converge for certain p-values, and it diverges for certain p-values. Okay, so it will diverge. I know it diverges if p is 1 because that's the harmonic series. And so it would diverge for p-values that are 1 and less. And it will converge if the terms go to 0 faster than anything faster than 1 over n, essentially. So that would be anything bigger than 1 for that p-value. There we go. All right, the comparison test says if you have this lineup, so your terms have to be positive, and the terms for, you need to have the terms all less than the other terms for depending on how you're comparing it, then if the sum of, let's see, all the b sub n's converges, then the sum of all the a sub n's will also converge. And then if the sum as n goes from 1 to infinity of all the a sub n's diverge, then, oh, I'm running out of room, sad. Then the sum as n goes from 1 to infinity of all the b sub n's also diverges. There we go. Okay. And you'll just have to stay tuned for the next set of videos to learn about the limit comparison test. But don't forget to update your flashcard collection when you see it. Take care, everybody.